Okay. Now, the Venn diagram in grade 10, it consists of a rectangle. It consists of a rectangle. Okay. The rectangle represents the sample space, right? So you can have two events A and B. So event A and B, they will be part of the sample space. Okay, please don't draw that. I'm going to show you the proper diagram to draw. Okay, so with the Venn diagram, we use it if we have got a very complex probability problem. Okay, now the Venn diagram consists of two events in grade 10. So we can have two events, that is event A and event B. Those two events must be inside the sample space. Now, a sample space will be represented by a rectangle. All right. Now, this type of a diagram is the one which you call a Venn diagram. In grade 10, we only focus on two events. As we move to grade 11, we'll deal with three events so that you can end up having three circles. Okay. So, what I would say diagrams, okay, at this stage, you can have three possible scenarios. Okay. So, we've got our rectangle, which will be our sample space. Anything inside the rectangle belongs to the sample space. Okay? So you can have one event also representing the sample space. So you can have a case like that. We have got one event A, and that event may consist of all the elements in the sample space. That's also possible. You can also have some elements inside that circle and some outside. That's also a possibility as well. Okay, but in this case here, event A will represent the sample space. Then you can have a case like this one now, whereby you have two events inside the rectangle. Now those two events can have a point of intersection. The point of intersection tells you that there are some elements in A that are also in what? In B. Okay, I just want to give you an example. You must guide me. Right? How many of you are doing life sciences? How many of you? Okay, then you can just raise your hand, please. So those who are doing life science in this class, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are about 17 of you. Okay? And how many of you are doing physical science? Physical science. Okay. Let those who are not doing physical science raise their hand. Anybody who's not doing physical science? Can you stop that? Are you doing physical science? So 1, 2, 3. Is your hand up? 3, 4. Who else is not doing physical science? 1, 2, 3. How many of you are not doing physical science? Just raise your hand, please. I want to know so that I can be able to clarify the second scenario. So the 1, 2, 3, 4, 5. Right, so we've got 5 of you. Okay. Now, do you agree with me? Okay, how many of you are doing are not doing physical science? So it means in this class there will be 21 who are doing what? Physical science. Okay? 21. Now, all of you are doing maths, isn't it? Now, how many of you are doing physical sciences and are also doing life sciences? If you are doing physical science and you are also doing life sciences, can you please raise your hand? Physical science and life science. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 of you who are doing what? Who are doing both. Now, if I were to ask you, okay? If I were to ask you, can you pay attention? Pay attention. if I were to ask you, so you have got life science, and then you have got physical science. Okay? If I were to ask you, how many are doing life sciences only? Life sciences only. It would what? 3. Remember, these 14 here, these 14 are doing both subjects. So how many are doing life science only? It would be what? 3. And those 14, we put them there. Because that's the intersection. These 14 here, they belong to both subjects. Then, how many are doing physical science only? It will be 21 minus 14, which is what? 7. Are you following? So the total who are doing physical science is 14 plus 7, you get 21. Those who are doing life sciences in total, it will be 3 plus what? 14. So, yes. They are about 26. Okay, so, okay, look here. The remainder, okay, the remainder, that is about 5 people, they are not doing life science or physical science in the class. Are you following that? So if I add 3, if I add 3 plus, actually it will be 2 people. Right? It will be 3 plus 14, which is what? 17. 17 plus 7 gives what? 24. 24 from 26, you get what? 2. So there are 2 people in the class. I don't know who those people are. They are not doing life science, they are not doing physical science. But they are doing maths, by the way. Remember, all of you are doing what? Maths. I wonder who those 2 people are. Who is not doing maths or, sorry, physical science or life sciences?
They must be absent, sir.
Okay. All right. So, okay, I will check that. Okay, so here, the intersection, this area here, it tells you the elements or the number of people who belong to both events. Okay? It tells you the number of people who belong to both events. Right? Then, sometimes you can have what are called disjoint events. Disjoint events are events that don't have any intersection. Okay? Which means there is nothing common between the 2 events. Alright? Okay, so can you just copy that down? The interpretation. Right. Now, it's important for you to be familiar with the notation used when you are interpreting Venn diagrams. Now, in probability, when you see the word "and," okay, like in this case, you have got 2 events, A and B. This word "and," it means there are some elements that belong to both events. So there's an overlap. Okay? It's like this 14 here. Okay? So whenever you see the word "and," it tells you that there are some elements that belong to both events. Right? Now sometimes we can denote the word "and" with an intersection. The intersection comes from what's called set theory. Okay? Set theory, that's where the intersection comes from. Okay? So, you can have an intersection. Now, the notation used for the intersection is this one here. Okay? It's like this. It's an upside down U. Like that. That's the intersection sign. Okay? So you have got your intersection sign, which is written like that. Okay? Now, in my case, I'm not going to use the set theory notation because it's not part of it's not a major part of the curriculum. I'm going to use the word "and." Okay? But if you read some books, they will also use this notation instead of the word "and." Are you following what I'm saying there? Because I don't want you, when you see a book and then you see there's an intersection notation, then you say, Mr. Paula didn't teach us this. It's the same thing as the word and. Okay, if you use it, you won't be penalized. Is that clear to everyone? Huh? Then, in probability, there is also the word or. Okay? The word or. Okay? The word or in probability, it means the sum of. If you pay attention, pay attention. The word or in probability, it means the sum of. Okay? So it's also called the union. Okay? So we can say A union B is the same as A or B. Now the union sign is like this one here. That's the union sign. So I can write A union B. This is the same as A or B. And here I can write A and B. It is the same as A intersection B. You have to be familiar with the notation of the topic. Then you can also have neither A nor B, which means those specific elements will not belong to A or B. Okay, then we have got A only, like that 3 there, and the 17. You can have the B only there. Okay, so this is some of the notation that you need to be familiar with.